So this is the second part of 2.1 and 2.2. So the first question on the second part shows 3 diagrams: distillation, filtration, and evaporation. The student was given a solution of sodium chloride. State which method, A, B, or C, he would use in order to obtain a pure sample of water. Explain how the method works, okay? A, because you want to obtain pure water, separate a solution from a liquid to obtain pure water. You might then want to go on to say about how you would heat it up until it evaporates, and then it condenses. 500 grams of solution was found to contain 43 grams of sodium chloride. Calculate the percentage of sodium chloride found in the solution, so just a simple percentage. Should have given you 8.6. Group 7 ions, chlorine, bromine and iodine, can be identified using the silver nitrate test. Complete the table. Okay, so white, cream, yellow, remember they go down the group. A little bit harder now in terms of a flow diagram. Chlorine, sodium iodide solution, sodium halide solution and halogen A. Chlorine is higher up in the group, so it will displace the iodine from the sodium, so that's why you'd have iodine on its own. Something halide solution turns orange-brown, so iron chloride, and then again no reaction, something like sodium fluoride, because it's higher up in the reactivity series. Okay, that would then give off bromine. That sodium halide solution is iron bromide and displaces to give you chloride. Okay, aluminium reacts with iodine to form a compound aluminium trihalide. Write the balance symbol equation. Okay, so you get 1 mark for putting Al and I2. Remember, I2 is diatomic, and then 2nd mark for balancing it out. Silver nitrate can be used to detect the presence of aqueous iodine ions. The equation below represents the reaction occurring between silver nitrate and aluminium iodine. Ionic equation, so just the silver and the iodine reacting together. Okay, using examples of your choice, describe how flame tests and silver nitrate solution are used for the identification of ions in chemistry. So I've just gone through exactly how you would do it and what kind of results you would see. This question we've all gone through in class. Okay, identify the errors, give the correct observation. The first one I picked is lithium. If you notice, 6, 12, 13, that doesn't really fit the trend, so that realistically should have been 11. Potassium is not an orange flame, it's a lilac flame. How would you then test for sodium? Flame test should give you a yellow flame. How would you test for chloride? Silver nitrate and a white precipitate would form. Again, as you'll notice, this 6 marker comes up quite regularly. Another 6 marker then, this time they gave you compounds, so potassium bromide, barium chloride and calcium iodide. How would you identify them? So first thing you do a flame test to identify the potassium, the barium and the calcium, and then a silver nitrate test to identify the bromine, chlorine and the iodine. Okay. This question then is a reacting mass question, so use the equation known mass divided by known MR times by unknown MR. So if we work through the question, when carrying out a reaction, 120 kg of sodium chloride was found to produce 38 kg of sodium. Calculate the maximum possible mass of sodium that can be produced and use this to calculate the percentage yield. So the first thing you need to do is work out the maximum possible mass. Remember to include the 2's. Okay, so you find the known mass, which is sodium chloride, and you know that MR, so you can work that out. 117 because you times by 2. Then times it by your unknown MR, and that gives you 47.2. So that's the maximum possible mass that can be made. Then do a percentage yield. So it only made 38, but you know it could make 47. So what's the percentage yield? 81%. Suggest a reason why yield is less than 100%, not completely filtered, was lost when transferring. Suggest why this reaction must be carried out under dry conditions, because sodium chloride is really soluble. They've given you equation then to input to work out percentage abundance. So you just do the mass times by the percentage, divide by 100. Okay, and it just gives you an overall mass, exact mass. State the difference between atomic structures of lithium and lithium-6 and lithium-7, different number of neutrons, because they've got different mass number. Again, another quite nice, easy mathsy question. State how many carbons are present. So it'd be 1, because there's no little number next to it. Give the total number of atoms, so 2 potassiums, 1 carbon is 3, plus 3 oxygens is 6. Calculate the percentage by mass of carbon in potassium carbonate, so work out the entire MR, which I did there. Total is 98, and then you're looking for the percentage by mass of carbon, so it'd be 12 divided by 98. A balanced symbol equation between sodium and oxygen is given below. Calculate the mass of sodium oxide that will be produced when 0.7 grams of sodium is burned in air. Okay, so again, this is a reacting mass one. Known mass over known MR times by unknown MR. Okay, so the known mass is sodium. Again, take into account the 4, keep the numbers. So that'd be 94 times by the MR of the unknown one, and that would give you a mass of that. You know it's kind of right because they stick to the same kind of thing. If you ended up with like 95 grams of something and you'd only had 0.7, then you know that something's kind of gone a little bit obscure. When the reaction is carried out using 0.73 grams of sodium, it is found that a mass of 0.338 grams is produced, so do a percentage yield. So that's the actual mass over the theoretical mass times by 100. So that's that's not a very good one, 34%. If no product was lost, suggest one possible explanation for the percentage yield not being 100%, not filtered properly. Another kind of mathsy question, this time is working out empirical formula. Sometimes they call it simplest formula, so don't get confused by that. Okay, so put them kind of like in a table. So you know the mass of carbon is 9, you know the mass of hydrogen is 2. Divide them by their ARs, so what you find on the periodic table. So their mass numbers. Okay, AR when they're like an element on their own, MR when they're in the compound. That should give you 2 numbers. Divide by the smallest. And then that gave me 1 and 3. Okay. Calculate the percentage by mass of carbon in butane, an alkane that contains 4 carbons. Okay, so I've given you the compound there just so you can work it out. So work out the MR, which is 58, and then percentage of mass of carbon, so 48 divided by 58, times it by 100. Another 6 marker, okay, so this topic often comes up as a 6 marker. Describe how reactions involving chlorine, bromine and iodine can be used to show a trend in reactivity. So you can use the reaction with iron wool, so the fact that fluorine reacts almost instantaneously, whereas bromine has to be heated before it can react. I've just included a symbol equation. The more reactive halogen will displace the less reactive halogen. Fluorine is the most reactive, so will displace chlorine. Okay, and you can do displacement reactions. You'll also notice colour change. Right, so another periodic table, group 7, group 1, 6 marker. So it talks about how elements can lose or gain electrons. Everyone wants a full outer shell. Group 1 elements are more reactive down the group as the outer electron is further away from the nucleus, so there is less of a positive and negative attraction from the positive protons and the negative electrons. Group 7 is a little bit different because it needs the nucleus to pull in the final electron, so they're more reactive at the top of the group. This question then says, when potassium reacts with water, it fizzes, giving off a colourless gas. Name that colourless gas. It's hydrogen. Describe 2 other observations that you can make when potassium reacts with water. Spinning around the bowl, lilac flame, you'll also hear a squeaky pop, which would come from the hydrogen gas. Universal indicator turns purple when it's added to the water after the potassium has reacted. Explain the observation and name the product that caused this. Potassium hydroxide. So potassium, when it reacts with water, turns into potassium hydroxide, and you have the hydrogen gas as well. Obviously that isn't balanced, so that's what causes, because potassium hydroxide is an alkali, all hydroxides are alkalis. Give the name of a group 1 element that would react less violently than with water than potassium. That would be sodium, because they get less reactive. The ones at the top are less reactive than the ones at the bottom, so potassium is below sodium. This question then is kind of carrying on. It says, name. The student carried out 2 chemical tests, and these are a result. So the yellow flame test tells us it's sodium. The silver nitrate tells us it's iodide. And that's how you'd form your compound. The metal always goes first, and sodium's the metal. Again, another 6 marker. This one's looking at what would happen when you put all of group 1 in water and talk about the similarities and differences. So they'd all fizz, but obviously as you go down the group, they get more reactive. Talks about potassium bursting into a lilac flame. All solutions will turn pink, so another similarity is that alkalis, or purple, turn into hydroxides. The more violent reaction, the more negative the alkali. Complete the balanced simple equation for the reaction of oxygen. So they again react with oxygen, that's them reacting with water. So when they react with oxygen, they form metal oxides. What you have to do, so sodium's positive, oxides 2 minus, do the crisscross method, so 1, 2. So 2 sodiums for every 1 oxygen. That would get you 1 mark. And then balancing it out. So obviously if you put a 2 in front of there. Now what you could notice here is oxygen is 2. So you've obviously got to put a 2 there to have 2 oxygens. Then you end up with 4 sodiums. So 4 sodiums on this side. Iodine gas is being made, chlorine is displacing it, form the compound, okay? The reason for the colour change, pale green, that would be the chlorine gas, and then it turns to brown when the reaction occurs. Right, the balanced simple equation for the reaction between chlorine and potassium. So chlorine displaces the iodine, and so you end up with iodine on its own and chlorine attached to potassium. Simple equation for the reaction between iron and chloride is shown. Calculate the mass of chlorine needed. It's a reacting mass question, so known mass over known MR times by unknown MR. Okay, remember to include the big numbers in front. Okay, obviously any other numbers as well, but it's so important that you include the big numbers in front to make sure that you get a correct ratio. Again, looking at one number, so their numbers are quite similar, so that means that you should have got it right. It then goes on to say about balancing an equation. The easiest way to balance this equation is there's 2 chlorines on this side. There's no box, so that means there has to be 2 chlorines on the other side because it has to be exactly the same. So you have to put a 2 in front to get you 2 chlorines. 2 times by 3 would give you 6 bromines. What times by 2 would give you another 6 bromines. Okay, percentage yield. So it said that it should make 27.5. It only made 21.34 times by 100. So actual yield. Actual over theoretical. Okay, actual over theoretical gave you 77.5. I rounded it up to 78. Final question then. Describe the trend in melting points going down the group. So as you go down the group, the melting points increases because they're getting closer to 0. Be careful, that's a common mistake to make when they've got negatives in front. Use the data to estimate the melting point of argon. I went with 200, which would be bang in the middle of them two. All group elements are gases at room temperature. State how this information on the table supports it. Their boiling points are below room temperature. Okay, so remember, melting turns from a solid to a liquid, boiling liquid to a gas. So room temperature is around 25 degrees, maybe 22. So if you were a liquid at room temperature, you'd have to have a boiling point above 22, and these do not. Helium is used to fill party balloons, give one property not shown in the table that makes it suitable, unreactive, okay? The other thing with helium balloons is its density, but that's shown in the table. Under certain conditions, xenon can be burnt with oxygen to form xenon trioxide, help you balance the equation. That was a hard one, okay? Because there were all 3 boxes, so that took a little bit of trial and error.